Is my screen is visible? Hello? Hello? Is it visible now? The screen? Hello? Hello? Somebody please reply.
Yes, sir.
Okay.
Yes, sir.
Just a minute. Let me make sure that it is recording. It is recording. So in this one, now we'll move on to second module, that is tools for design thinking. What are the various tools we use for design thinking, right? So many times when you are working in the first module, you learn that design process, team-based design, many people are involved in the design. Right? So those might be sitting in a single office space or sometimes different offices and in different cities in the different parts of the world. Okay, so in such cases, so what are the tools required for the design things, such things we must understand in this class, this module. So as we discussed that many times client will be sitting somewhere else or some different expert teams are from client sides, and they also mean big projects in MNCs and all. From client side, they also appoint some engineers, right? They go through your quality of the work, what you're doing, all those things. They also do the checking and all those things, right? And execution team will be there somewhere if you are designing some product which needs to be manufactured. That will be somewhere else. It is located. So maybe many of the fabrication works, steel fabrication works, and all, and also even in mobile fabrication works are laptops and desktop application work, that will be done in China because of cheap work labor and all those things, right? So because of such diversely located workforce, okay, so you need to make them collaborate in virtual space. For that real-time design interaction capture and analysis system, that is called real-time design interaction capture and analysis. What is the interaction between the design team and manufacturing team, right? Our clients and customers, all those things needs to be recorded and captured and analyzed, right? So it is uncontrovertible that communication plays a central role in collaborative activities such as engineering and design. The success or failure of complex projects is essentially, it is depending on the how the individuals in different teams communicate and they interact with each other to request information, negotiate, generate ideas, make decisions, or resolve conflicts. If any conflicts are there, if they have done any, if there are any queries raised by the clients or uh, engineering consultancies team or uh, such things, or quality team, if they raise any queries, how they resolve them, right? How they interact with the different levels in a team, right? Team lead will be there, okay, and under the team, many design engineers might be there, draftsmen might be there, who they do the modeling of the 3D modeling in a computer. They do, or see if they give any plans and design plan, they draw it on the using some software to show the manufacturing drawings, right? That we call it as fabrication drawings, right? When we are, how we communicate to the manufacturing team or manufacturing team is through the drawings only, fabrication drawings, engineering drawings. Many people, they just like our engineering, for common peoples, different languages are there for communication. For engineers, drawing is the language most of the time, right? We draw it and we'll send it. Just in civil engineering, we create the plan drawing and cross-sectional drawings of the different column elements, beam elements, and reinforcement drawings, all those things we create. Or even if you go to the mechanical engineers, different parts they drawing they create, right? So including the dimensions, right? and what is the type of the connection they must make, whether it is a welded connection, bolted connection, or riveted connections. So all those aspects should be mentioned in the drawings, right? That is how they communicate and interact with each other, right? So therefore, in this regard, we must develop a team, so which had a strong need exist for design teams and researchers alike to be able to inspect and observe team communication early and during project time runtime. Okay, so in order to make this effective communication between the different teams, right? So which we must develop a system which will make them to inspect and observe the team communication activities, right? In many companies and all, there will be a one position is there that is called document controller. The document controller, what is the role of the document controller? He is the central point of the communication. In my company, one document controller is there, or in client side, one document controller is there. All the communication needs to be happen through that person only, right? So there, thereby they can record the what is the revision of the drawings sent, or what is the revision of the query sent, or revision of the design sent, because any design cannot happen in a single shot, right? Many times they do the revisions in different companies. They have a different notations for revision, R1, R2, R3, or some companies they may give different notation, REEV 0, REEV 2, like that, in along with dates also, right? So such things are different mechanism they have to make, right? However, new techniques are required to efficiently study team interactions during the early stages of engineering design projects, right? For this also we must develop a new techniques, because when your customers are when the clients and design teams are located at the different part of the world, you must develop a different techniques. The augmented virtualization and geographic dispersion of team environments raises demand for an adaptive computer-supported design research methodology, which takes the increasing role of online communication into account, right? So many times we go for the augmented virtualization, right, of team environment, right? So which will allow the different teams for an adaptive and computer supported design research methodology, right? Different companies, they have a different computer system methodologies. Even if you see in our college, we have a SIMS called SIMS, right? Online monitoring system and all. So whatever we have to teach, we need to lesson plan, we need to make in advance before the commencement of the semester. We need to put the lesson plan. Once we do the lesson plan and all those things, right, we need to update every day whatever the teachings we do, and notes and materials are also we are keep on posting. And any faculty, if he wants to apply for leaves, he has to apply through online system and all those things. Such systems are there, so which will help to function this engineering college effectively, because different departments are there, various departments are there in the same engineering college, right? So this will help the management to monitor the activities and all. So in this effort to construct, apply and evaluate an automated approach to design team observation, the following research question needs to be answered in order to develop an efficient system for the real-time design interaction monitoring and all. So we need to ask some questions. So what are those some questions, right? Chronological modeling, right? Design interaction should be chronologically modeled and represented in a computer processable format, right? Because we use high level, our language is called high level language, right? What computers they use, that is called machine level language, right? So if I say some intelligent means we can humans can understand, but computers and all, what is the parameters to give for intelligent, right? What are the parameters we must give to make the computer to understand intelligent means? Whether IQ, right? It is a concrete question. Intelligent is an abstract answer, right? That is not a measurable quantity. So how do we make it measurable? We may give IQ or EQ, emotional quotient is there. Different parameters are there, right? Are the skill set of a particular person? Such things are there, right? If such things are there, or what is the progress of the work, or how much percentage it is finished, right? All those things should be chronologically modeled and computer processable format, right? Second question, and what are the structural dynamic properties of software system that facilitate the real-time capture and analysis of design interaction in a technology-enabled environment? Okay, right? Many softwares are available in industry, right? So which are designed based on the to make them by keeping in mind the structural and dynamic properties, right? What are the organization structure is there should be included, and what is the timeline? Different timeline needs to be monitored. Dynamic is one which is varying with time. That is called dynamic, right? So which is varying with time. So keeping them in mind, we need to develop a real-time capture system. Right? First one is chronological modeling, and second question, what comes is the structural and dynamic properties, which will facilitate the real-time capture and analysis of the design interactions. Right? So generally, in civil engineering projects, what we do, very first step, chronological, if you want, first we'll give the drawing of the columns marking, right? Or wall marking, foundation for the foundation. There we dig the foundation. Then we give the foundation drawing. Okay, then we give the column reinforcement drawing, right? Then we give the beams, slab reinforcement, all those things step by step. That is chronologically we are giving, right? And structural and dynamic properties of software system that facilitate the real-time capture, right? So in the software, if I want to make the, if I want to capture the construction activity, so what I can do, I need to make the structure of the software to receive whether the materials, first material there, whether it is received, or whether the foundation drawings it is received, or whether beam column drawings it is received, right? All those different elements, structural elements, whether they have received, all the different structural components I need to make. And also I must assign the time schedule to make it dynamic one, right? So many times when we design the IT software, even in civil engineering also, or in different mechanical engineers also, they use different softwares, right? Those softwares are designed by keeping universality in mind, right? Many mobiles are there, laptops are there, computers are there. How they design? So they are not designed for the only for specific Indian users, right? They are designed for the keeping in mind universality in mind. Many people across the world, they must use such softwares. So these softwares needs to be configured in such a way that which allows reacting appropriately to arbitrary social interactions and informal behavior. Right? These softwares, a facility must be made to react appropriately or sometimes arbitrarily, just like your mobile and all chatting, what you do, sometimes you write a complete message, sometimes you can use the emojis and all, right? So these will capture the informal behaviors, right? On the other hand, the system needs to apply well-defined and precise semantics in the encoding of the design process in order to ensure the validity of the formalization, right? These semantics, you must use a suitable semantics for a particular type of the product you are doing, right? So if you come to civil engineering, we have a different semantics. Semantic means linguistic parameters, right? So are the meaning of the word meanings, right? So they must be related to the particular type of the domain to which you are designing the software. Or if you are designing a software system for the medicine industry, so what are the semantics to be used? Precise semantics, those things you must understand by interacting with the clients, and you can empathize their situation and you can design the software. And further comes the balancing between flexibility, adaptability, and formalism is one challenge in the design of a generic technological foundation for real-time team diagnostics, right? So balancing with flexibility, a software must be, the product must be flexible, right? If the customer, if he wants to add some additional features to that one, right? Or he can make some arrangements within the software, customize within the software. And the software should be adaptable to different types of the work groups also, right? And formalism is one challenge in the design of a generic formalism. What are the formalities they use, right, in those software, right? So these are some of the challenges which are involved in the generic technological foundation of real-time diagnostic. Generic means it's a group of things, group of technological products what you are designing. In such cases, they must be flexible. They must be adaptable to different conditions, work group conditions, and what are the formalities they use in different groups, right? All those things should be incorporated in the software or in the interaction system what you are designing, right? And next we'll discuss about the can digital traces of communication be a surrogate for team behavior, right? So can these digital interaction can completely replace these offline or closer group behavior, like just like we do in companies and all, people are sitting together, right? So or hard copies of the things what we collect or video recordings what we do. So can these digital traces completely replace such things, right? Because whatever the digital traces we take, they are low level data, right? They are using the machine language, right? So many of such things are can be understood by the engineering or suitable technical team only, right? And many times, if it is not chronologically organized, if the documents what they keep or the data or records what they keep, if it is not chronologically ordered, then it becomes very difficult, right? And also, if you want to record, keep a track or record of these digital communications, right? You must formalize suitable encoding of the online communication and its semantic value in a collaborative environment are relatively unexplored, right? So these encoding, any online data is saved, right? How to encode that one? Sorry, what are the semantics or syntaxes, or what are the linguistic phrases which can be used for the recording of these collaborative environment are still not explored completely. But still we can make it successful. Many times we can make such things workable or successful when there is a good understanding. When both ends they try. If two ends, if people are sitting at one end and the other end, they are cooperating, right? If they raise some queries, if they have not understood properly, right, then these things can become success, right? Many times in our classroom teaching also we are talking only, but sometimes we don't understand whether you are understanding or not, right? If you don't understand, you will raise the question, right? Similarly, there in virtual interaction also, using virtual softwares and all, there in such interaction also, the both ends must raise queries to understand the concept clearly, what the clients want or what is there in designer mind, right? Such things. And for this, most commonly used model is Shannon and Weaver model of communication. So is the most commonly used for non-interfering approach to communication capture. Right? So this figure shows the such communication capture system. Right? So first there will be an information source will be there. Right? So that information source may be either audio or video it is there. And from that audio to video, it is what it does. A transmitter will be there, which will encode it. It will come convert it into machine level language, something, right? And through the channel, it is sent to the receiver. Okay. So again, receiver it will decode it and deliver to the destination. So who is there in other end? Just like your online meetings, video conferences, or phone conversation, right? Whatever the conversation you do, those things can be converted into digital format, coded and transferred into digital format and sent it to the person who is sitting at the other end. Through the help of the receiver, the message is decoded and finally he is able to listen or watch what the other person from the other hand has sent, right? In such cases, various channels might be used, right? These channels must be capable of disassociate these messages from the noise source and all those things, right? For that, many technologies, noise filters are there. Okay, they might be used in such systems, right? So next we have a real-time design research instrument, right? So here, what are the real-time design research instrument which we can use, right? So here we must articulate an extensible software architecture of distributed and loosely coupled sensor and monitoring components. So these are the essential requirements of a real-time design research instrument, right? So there must be an extensible software architecture, right? So where just like our operating system, right, where we can install many software. Teams is Microsoft Teams is there, Google Meet is there, right? And Zoom is there. Okay, such extensible software architecture must be there, right? And also loosely coupled sensors must be included there in order to monitor the components, right? If any like sensor like maybe audio sensor or visual sensors, right? Such things must be included. A collections of softwares are available in the markets which will provide the required functionality to incrementally capture and query detailed communication properties immediately during the course of collaboration, right? So in market, many such softwares are available, just like I mentioned the Teams. Teams is there, where you can make the online interaction, or sorry, Google Meet is there, or Zoom is there. So and WebEx software is there. Such tools are available, right? Or sometimes you can also use the Google Drive, Dropbox is there, OneDrive is there from Microsoft Teams, right? To store the data, to transfer the data, big data from that, right? So, so if you are using such tools, this will establish a central point of access to information about how design teams virtually communicate over time, right? So using those software that will act as a central source of communication. If you go to different companies, okay, so they have a particular email system. They subscribe to particular email system. In our college, we have subscribed to Outlook, right? If you go to some other college, they subscribe to Google, or in companies also, many companies they are also using the Microsoft Teams, right? All the uh, official communication has to made through those mails only, right? So thereby that will act as a central point of access for communication, right? So we are not supposed to use our personal mails, personal email IDs, right? All the official communication must be made through the professional email IDs, right? So again, for this one, distributed engineering design spaces in which computer mediated team interactions are necessary. So okay, all these interactions what we are making are the computer mediated team interaction only, right? So when I take this class, after the class I can download the attendance also, right? Whatever the meetings we have made, everything is recorded here. Even video also I am recording, right? So this is computer mediated team interactions, right? So this service approach to communication, capture and analysis facilitates a symbiosis between design practice and research, right? Even the design practice and research, they can coexist, right? Together they can contribute for the development of the any particular type of the product or design of the products. Many times, many design parameters are not, so far they are not defined. In such cases, we may also have to contact research teams, right? Many design standards might not be established. Something new product if it comes, right? How to make the design approach for such products? For that, we must contact the research team also. So if that research team facility is not available, sometimes we may have to go for the research, right? And for the design researcher, the system acts as an instrument to collect data, right? So whatever the system, communication system, online interaction system, what we make, through that also they can collect data, right? Through the phone also, many times we do the field survey, right? So researchers will go to the field survey. So how they, sometimes instead of going for field survey, they can even make a phone call to the consumers or the persons to which they want to ask queries, ask questions, right? Or sometimes you can also use the, you can also record their answers, right? Such things you can do, right? Many times if you send the questionnaires to the consumer or the people who you want to do the query, right? They sometimes they may not answer the questions, they will not reply. In such cases, personally, if you call them and you can quickly, you can catch them by off guard and you can ask questions from them and you can record their responses, right? For research team also, these real-time interaction systems act as an instrument. There are number of client applications and channels are available, right? Those I think you know, Microsoft Teams, Google Teams is there, Google Meet is there, Zoom is there, right? Such things are there, right? And even different companies, industrial sector, they also may have the different some suitable mechanism. At the same time, the services provide the functionality to measure trends and characteristics in the recorded events and to systematically explore the past and present of communication behavior in the observed teams. When these recorded events are systematically recorded, right? Online design interactions, right? How much task is completed and all those things, it will give from here through this, by using these computer system or real-time interaction system, you will get the concrete data. So in terms of numbers, there you can plot a chart of progress of the work or the whether we are in line with the schedule or if any manpower needs to be increased. All those things can be decided. They can be extrapolated, right? If the speed of the work, some work is design work is this is the speed, right? And in from this speed, I can extrapolate how much time I require to finish this remaining work. Such things are there. And conceptual design methodology can also be developed and tested, leading to a deeper understanding of relevant matrices in team communication, right? By using these virtual systems, right? Virtual interaction and all those things, we can put the concept on the paper. We can bring the concept on the paper and methodology, what can be used, right? We can ponder on the concept and methodology, and also we can list out the various parameters, right, which can be included or which can be worked out to finish any particular product. And further completing the symbiosis, the set of services can be iteratively defined and adapted to form the basis for improved guidance, management, and design process, right? So you, by this continuous interaction between the design team and research team, or through this, or from design team and clients or customers, right? You can iteratively refine many times when we do the, most of the times, right? When we do the projects and all, when we send it to clients, at the first go itself, he will not agree, right? So he will ask us to refine, or he may also ask to some more component to be included, right? So through how it is possible, through this interaction only, real-time interaction only, right? So last class I was mentioning, right, in when I was in the working in industry, we were using a software called Plant Design Management System (PDMS). So there different teams are involved. So civil team, mechanical team, instrumentation team, electrical team, such teams were involved, right? So everyone were updating their model in the same model which is kept in the server, right? We were accessing the same model from the different systems, and we used to update our elements in that model, right? So thereby we could able to see dynamically the whether our work or engineering beams and columns, whether they are abstracting with the equipment from other team, such things were there, right? So those things we could able to check immediately, right? So you can see the design process. What we do generally, a design process is there, which is sent to the, which is captured and analysis services were made, right? Which is sent to capture and analysis service system, right? Design process what we do, and they are sent to the capture and analysis system, right? And from that capture and analysis system, it is then transferred to design research team. So design research team, it will verify it, right? If it is okay, right? And they can postulate the metrics and theories or hypotheses they can make, and final product they make. Or if it is not satisfied their requirement, design research team, they will give the feedback and of the refinement, which is sent to capture and analysis services system. From that capture and analysis service system, again it's sent to the design process team. So here, capture and analysis service system will act as a central point of communication, right, between the design process team and design research team. And similarly, you can have many other sub teams also, like customer team, consumer team, or market team, financial team. So all the teams can also be involved, right? And they send their all feedback to the capture and analysis service system, which then send information to the design process team, right? So next topic we'll discuss is capturing design team activities, right? So to do this one, you must develop an appropriate data model which will describe the individual communication activities of design teams. And then, while the observation of technology mediated design activities has been the subject of many previous works, a more flexible and generic approach is required, which supports real-time application in the diversity of existing and future IT supported design environments, right? So so here again the repetition of the same points what we discussed there, right? What is the structural and dynamic model of the data capturing system, right? And it should be more flexible and generic, right? That is a group of approaches, different group of approaches, still not yet been satisfactorily devised, right? So here from one point on, here I also have a limited resources here, right? So if I want to, since it is okay theory subject, right? If you ask any questions, I can answer directly. But if it is some mathematics or some other subject, so if I want to answer your queries, right, I need to write something, some equation or some number, I need to write, right? So it should be dynamic. My response should be dynamic. Dynamically, I should also be capable of writing. If I say equation or something as complex equation, that may not go into your mind. Such flexibility is difficult, right? Many times our laptop we don't have a touch screen laptop, right? So if I want to draw using mouse and all, it will be difficult, right? So writing is very, very easy compared to drawing something in computer, immediately drawing in computer, right? So those are some difficulties, so which needs to be addressed, right? There are so many such difficulties might be there, right? Again, different companies, even where to store the data, right? What is the format of the file name, right? When you want to search, when thousands of files, such files are there, if you want to search for a particular file, all right, how you must name it, right, so that it is easily accessible, right? In our small system also, if we store some file or something, right, so it is difficult for us to access that one. And if you go to industries, thousands of such documents are there. How to access the documents, naming formats, everything, such things needs to be standardized, right? So let us stop here, and so remaining thing will go in the next class.